So on this problem, you're asked to find the length of the curve, x equals the integral from 0 to y square root of 6 secant to the fourth t minus 1 dt on this interval. That looks kind of scary, but it's exciting to think of an integral as an actual function that defines a curve. I think that's kind of neat. It also makes this problem, what can be really difficult, pretty easy, because the formula for a length of a curve is the integral on over an interval from a to b is the integral a to b square root of 1 plus dx dt, dx dy squared dy. And what's neat here is you remember from the fundamental theorem that if you wanted to find the derivative of this x equals the integral from 0 to y, this function, the fundamental theorem of calculus tells us that it is basically just this interior function with y inside it. So you would have learned that in Cal 1. So you can immediately see here that dx dy is just going to be equal to the square root of 6 secant to the fourth y minus 1. And what's cool about that is that when you square it, you're just going to get 6 secant to the fourth y minus 1, and then you have the plus 1 here, and so the ones will cancel. So we'll just write this as the integral from negative pi over 6 to pi over 6. I'll go ahead and show that step. It'll be 1 plus this thing, which was the square root of 6 secant to the fourth y minus 1 all squared dy. So again, you'll see that this, when you square the square root, it undoes each other, and then the 1 and the minus 1 cancels. So you're just left with this 6 secant to the fourth y under the square root. So this is going to simplify to negative pi over 6 to pi over 6, square root of 6 secant to the fourth y, and then dy. Now, this 6 in front cleans up as just the square root of 6. That's just a number times the square root of secant to the fourth y. You can split up a radicand inside when it's multiplication. So you can think of this as negative pi over 6 to pi over 6, square root of 6 times the square root of secant to the fourth y dy. That's totally a legal move. And then from there, let's see if I can get some more. Sorry, I need to get a little bit more room. Let's see, from there, that square root of 6 is just a number, so it's just going to tag along. And then negative pi over 6 to pi over 6. And the square root of secant to the fourth y is just secant squared y, and then dy. And of course, the antiderivative of secant squared is tangent, so this is going to be the square root of 6, and then tangent y evaluated from negative pi over 6 to pi over 6. And so you remember the tangent of y is the sine of y over the cosine of y. So the tangent of pi over 6 is just going to be the sine of pi over 6 over the cosine of pi over 6, which is equal to 1/2 divided by square root of 3 over 2. And when you reflect that, that's going to be 1 over the square root of 3. And tangent of negative pi over 6 is, tangent's an odd function, so that's just going to be the negative of 1 over the square root of 3. And so this is the square root of 6 times the tangent of pi over 6, which is 1 over the square root of 3, minus the negative of minus negative 1 over square root of 3. So this is square root of 6 times, right, you've got 2 over the square root of 3. And then that's kind of weird, but you can clean up the square root of 6. You can think of that as the square root of 2 times the square root of 3 times 2 divided by the square root of 3. Then your square root of 3's cancel, and you get 2 on the square root of 2. So that's how you get to that answer on this one.